We're gathered here on the bow of the Thompson to witness a technological first for Neptune Canada. We're bringing our vertical profiler system all the way up to the ocean surface. This is an instrument package that lives on the seafloor at 400 meters depth. It's a huge buoy made of syntactic foam, and implanted in the foam are numerous oceanographic instruments. What the buoy is meant to do is to rise to the surface slowly at about 20 meters per minute, several times per day, measuring oceanographic conditions in the different layers of the ocean all the way to the top. But we've never dared to bring it all the way to the ocean surface and into the swells before, because we're a little bit worried about how much the winch can take on the seafloor and about the cable jumping off of the winch. But as you can see, we have a flat, calm day out here today, so we thought this was a perfect opportunity to do a test, to bring our VPS, the vertical profiler system, all the way up to the surface so that we could have a good look at it. We could test how it behaves mechanically in about a 1 meter ocean swell that we have out there today, and also to give the radiometer, the sunlight measuring instruments on the VPS, an opportunity to get full sunlight outside of the ocean water. This will be coming up in just a few moments. We've just got our group positioning with the Zodiac off the bow to get even closer look at it than we can see here from the ship.
Okay, so we've got a visual on the VPS float.
Ari, we've brought the VPS now up to a depth of 1 meter below the surface, and we're in a 1 meter ocean swell. So that means that it's going to occasionally bob to the surface and see daylight, so to speak, in between the swells. We're just waiting for this to happen now. There it goes. There's our first glimpse of the VPS.
Yeah, so we've got the VPS on the seafloor, 400 meters depth, and it's run its buoy profiled all the way up to the surface. Right now we're just a couple meters below the surface, and we're just doing the last couple of meters in that profile. So the VPS float's packed full of instruments. It's got a hydrophone on it, it's got radiometers, a CTD, a CO2 sensor, a nitrate sensor, probably a couple layers that are missing. The instrument lifespan is about 2 years, so we plan every 2 years we'll recover the VPS, service the instruments, and put it back down for future science profiling. The plan is to cycle the VPS and do 4 profiles a day. Right, the main purpose is to calibrate the radiometer. Radiometer measures the attenuation of light in the water column, but it needs to know how bright the sunshine is at the surface so that it can tell the difference between sunlight at the surface and then the brightness of the light at depth for the top 100 meters of the water column. So we've successfully surfaced the VPS. It's gone high enough to calibrate the radiometer, and we're going to send it back down to 200 meters depth to do further calibrations. This is the first time the VPS has ever made it all the way to the surface.
Oh, this is the first time.
It's been a very challenging instrument to get to work.
Goodbye, VPS.
Bye.
Yes.
When are we going to see VPS again?
We'll have to come back next year for the VPS.